here. First thing we want to do is start by following direction. So plot the points and connect with the line. So 2 comma negative 6. Be very careful. Count the squares exactly. They're kind of small. 1, 2, down 6. 1, 2, 3, 4, 5, 6. And 4 comma 7. I know 2 over and down 1. That's going to be 4 comma 7. We plot the points.
You said it's negative 7.
Negative 7. And count the slope. We know it's going to be what? Down. The slope is going to equal. We have to go down 1, negative 1, and then right 2, positive 2. And we can use that and help us complete the line a little bit. So down 1, right 2, down 1, right 2, and so on. Just until you have enough to give you everything you need to make a nice straight line. So, and always draw your line all the way across the whole graph. Don't just connect the 2 little dots here. That's not a line. That would be a segment. Or a line. Line keeps on going in both directions. Now, based upon this, what is the y-intercept? What does b equal? By looking at the graph? Negative 5. So this is where we first started out, right? You had a graph, you plotted the points, you can actually count the squares for the slope, and you can actually see where the y-intercept is, where the line crosses the y-axis. And from this, you're able to get the equation. Y equals mx plus b. In this case, m is 1/2, b is negative 5. And that was the equation of the line. No problem. We did take a couple days to do this. Okay. We talked about positive slopes, negative slopes, all that stuff. So hopefully before you started this, you already knew it was going to be a negative because it's going down. So we did spend a lot of time just to get to this point where we can, in 20 seconds, go ahead and get the equation of the line easily. We talked about zero slopes, undefined slopes, and the difference between those. And then just last week we said, well, what if we want to do this without using a graph? How can I get the slope without a graph? How can I get the y-intercept without a graph? How can I get this equation if I just have these 2 points, but without a graph? Okay. So we're going to go ahead and do the other methods. But of course, as we're doing this, we should get the same exact values. So if I found the slope for another way, I should still get negative 1/2. If I find the y-intercept another way, I still should get negative 5. So we go over here, follow these directions, find the slope using the formula. Okay. So we have, what goes on top? And what goes on the bottom? Alright, so what do we have on top? Negative 6 and negative 7. The y values, the up and down, the rise. On the bottom, 2 and 4. Good. So negative 6 minus a negative 7 would be 1. 2 minus 4 is negative 2. Now, no surprise, right? That this answer has to be the same as what we got over here from what we counted from these 2 points. We have to get the same thing. And that's really why we're doing this, is to tie together everything. We went down 1, right 2. That's why we got this equation. If we solve it without a graph, we still should get the same thing. Also a reminder that what if I found the slope of the other direction? What if I found the slope from here to here? What would I get then? So there was a homework where we did it both ways. I think it was the first one. Just to show that if you find the slope going the other direction, you should get the exact same thing. So the big idea was that these 2 points make only one line, and that one line can only have one slope. So regardless of what method you use to get the slope, you better get the same thing no matter what. So having different methods does not mean having different answers. It's in case one doesn't work as well as the other. All right. Next we went into last week, well, how do I find this equation of the line, specifically the y-intercept, if I don't have a graph? So we said, well, we do know this, y equals mx plus b. And we do know what the y is, we know what the slope is, we know what x is. So with that information, we can figure out what b is. So what does y equal in this case? -6. And m is -1/2. X is 2. And of course, what answer are we expecting to get right here? What is the answer, by the way? -5. Yeah, it's right here. We already got it. Remember, we're doing another method to get the same thing, so it's not a surprise. So as you're doing this, don't be hoping or guessing. It's like, well, here's what I got. It should match. If they don't match, something's wrong. Either the graph you estimated wrong or your calculations are wrong. Okay, half of 2 is 1 in the negative. So -1 plus what is -6. And of course, no surprise here. -5 is b. Same thing, right? So whether we see it from the graph right here, y-intercept, or we calculate it using slope-intercept form, we better get the same thing. And just like slope, I could have used the other point and got the same answer. So -7 minus 2, add 2 to both sides, and we'll have -5. So -7 plus 2 is -5. So just like the slope, doesn't matter which point you use, you get the same answer. This is something you do when you have time, you do a check. If you use this point, you use the other point, make sure you get the same answer. Remember, there's only one y-intercept for this line, no matter which method you use. We are not finished. What is the equation of this line? Still haven't written the equation, although we kind of did already. We knew the slope was -1/2, and we found out the y-intercept is -5, but of course this just matches what we already got from the graph. So if these two don't match, something's wrong. Okay. Lastly, go ahead and find the x and y intercepts. So just to review, x-intercept is where y equals 0.
Can't see it.
And where y-intercept is where x equals 0. So as I was saying, you need, for the x-intercept, that's where y equals 0. And the y-intercept is where x equals 0. So we found the y-intercept yet another way. So start off with the equation that you have. And plug x equals 0 in there. x is 0 and simplify. Nice thing with 0 is that 0 times anything is 0, 0 plus anything is that anything. Really easy to work with. So we'll have negative a half times 0, which is 0. 0 minus 5 is negative 5. Which should be no surprise, right? Because we already knew what the y-intercept was. We found it here, here, and here, negative 5. So this is a lot of big picture stuff, showing that no matter what method you use, everything should be the same thing. The only thing difference with intercepts is that you actually write that as a coordinate. So we have x is 0, y is negative 5. But of course, we already knew that's what it was going to be, because that's what we got here, 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 and here. So when we say, what is the y-intercept? We use b. Oh, it's negative 5. Okay. But we could also say, well, what's the coordinate of the y-intercept? Well, this is the coordinate 0, comma, negative 5. So it's two ways of saying the identical thing. Something identical. Lastly, what is the x-intercept? So you can see here, estimate, what is the x-intercept? Where is it across the x-axis? So when we do it without a graph, you should already know what the answer is. Okay? So you can estimate, that might be around negative 9 or so. When you go here, do the same process. This time, make y 0. So we have 0 equals negative 1/2 x minus 5. Solve that. Add 5 to both sides. Right? And we get five is negative 1/2 times x. So half of what number is 5? 10. And then we have a negative here. So multiply by the reciprocal to show that we do indeed get negative 10 because it's a negative. And lastly, write your answer as a coordinate like we did here. So x is negative 10, y was 0, so this is the coordinate 0, comma, negative 10. I'm sorry, negative 10, comma, 0, which we already guessed, well, estimated anyway, earlier. Okay. So, right here. So we already knew when we started this, it had to agree with the picture we drew earlier. So that's what this is going to be for you to do, is showing that no matter how you get the slope, whether counting squares or calculating, either way, you should get the same slope. If you get the y-intercept from the graph, it should be the same thing as you get from here by using y equals mx plus b, or by plugging in 0 for x. You get the same thing. And of course, the x-intercept should agree here. So you're going to do this several times over and over and over to really get the hang of it. But the big picture is that if you get a different answer here than here, you don't just say, well, I did it, I'm done. You know that something's wrong because there's only one slope. There's only one y-intercept for any 2 points. Can't be different answers. Now, the most important thing that's going to come out of this is that some of these are not going to be nice y-intercepts. They're going to be a bunch of fractions. And that emphasizes why we need this non-graphical way of getting the y-intercept, because sometimes it's going to go through a fraction. You can't tell what fraction that is just by looking at the graph. you need a algebraic way. So if you get like a y-intercept of, -9 or -7/9, don't be surprised. You won't be able to tell it's -7/9 by looking at the graph, but that's where it really is. But in the end, how am I going to tell that you really understand this? Is that all these answers will match. This answer will be the same as these two, will be the same as this one. If that's not the case, something's wrong. Okay? Question? All right. Don't forget that one of these will be a vertical line, which has different rules. There's no slope, there's no y-intercept. It doesn't work if you say y equals. There's a bunch of different rules, so keep that in mind and make sure you ask lots of questions.